All right, now hopefully you've had a chance to graph these on Desmos or your graphing calculator and get your graphs. So the first thing I would do is I would go to Desmos. Here's your first graph. What I want you to notice about this is an exponential decay. The way that you're able to tell that this is an exponential decay, remember right here, this base is a positive and this piece right here, you have a negative. So that's going to tell you that we have an exponential decay. Make sure you always get your y-intercept from your Desmos. So here is 0, 3.718, and then get two other points on your graph. So here's not too bad of 1, 2, 2, and then here's another nice one right here, 8, 1.05. So you can go ahead and get those graphs from your graphing calculator or Desmos. All right, so let's take a look at what this graph actually looks like. So the first one we know the A value, remember, is your number in front of E, so that's going to be 1. Notice your R value right here, this is going to be negative 0.5. Now that is your number that's outside of your parentheses here. And since that's negative right there, that's going to tell us that that's actually a decay. Our H value is going to tell us how the graph moves. In this case, our H value, remember, is the opposite of what's inside of there. So it's actually a positive 2, and that means it's moved 2 to the right. The K value is 1. That's your number right here. And remember, this is the exact same thing as your horizontal asymptote. So in this case right here, we know our horizontal asymptote is going to be y equals 1. The domain is always the same for every single solitary graph right here. It's negative infinity to infinity, or all real numbers. Your range in this case, notice, is from your horizontal asymptote up. So my range is 1 to infinity. Once again, we're always going to use parentheses here because it's never going to cross over that horizontal asymptote. If we take a look at this, if we start moving on the graph left to right, my graph is going down and leveling off at your horizontal asymptote. So that makes this exponential decay. And then let's take a look at our end behavior. So as x approaches infinity, as x gets bigger and bigger and bigger, where is your graph going towards? It's actually going towards that horizontal asymptote, or 1. Okay, from the left-hand side, as x gets bigger and bigger and bigger, where's your graph going? It's going towards positive infinity. Okay, and remember, one of the two of these is going to always going to be following your horizontal asymptote. And just once again, make sure that you're plotting your y-intercept here. And remember, you can always get your y-intercept, okay, by plugging in x equals 0 into your equation. So you could plug in y equals e. You can plug in 0 minus 2 plus 1, okay, which is kind of hard to get sometimes without your graphing calculator, which is why I would use Desmos to get it. All right, so let's take a look at our second one. Now, our second one, just from looking at this equation, since this piece is negative right here, that's going to tell us that it's exponential decay, and that's because this piece right here, we know our E is bigger than 1, so that tells us growth, but then this negative 0.75 tells us that's decay. All right, so now what that looks like on our graph here is, here's our graph. Go ahead and get your y-intercept. This one's nice and easy, 0, 2. All right, plug in x equals 0. Now notice when you plug in x equals 0, you get e to the 0. Anything to the 0 power is going to be 1. So 2 times 1, that gives my y-intercept. Just pick two other points on your graph. They don't have to be perfect. And then go ahead and graph those. This one's not too bad, 1.97 or 2 and about 0.44. Go ahead and get those points, graph them, and then draw it. Now let's go ahead and get all of our information in our asymptote. So A, that's going to be your number in front of E. In that case, this is 2. So that's actually going to tell us, remember, that this is going to be a vertical stretch. That R value is negative 0.75. Okay, and that's going to tell you that that's actually a horizontal stretch. Your H value is the number added or subtracted next to X, and that's 0, so you don't have a horizontal shift. Your K value is the number at the end. In this case, there's nothing there, so it is going to be 0. Now remember your K value, this is the same as your horizontal asymptote, this number added or subtracted at the end. So my horizontal asymptote is going to be y equals 0. It's never going to go past that point. Domain is the same for all of these, negative infinity to infinity. Okay, your range in this case is going to be from 0 to infinity since it's above your horizontal asymptote. In this case, this is exponential decay. And the reason it's decay is because it's going, as you're walking from left to right, it's going down, 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 down. And then also you're going to check your base. And then this piece right here, your base is positive. This is negative. So since this piece is negative, that also makes it decay. Our end behavior model as x approaches infinity. So as I go bigger and bigger and bigger towards this side, okay, where's my graph going towards? That's going towards my horizontal asymptote is 0. On the left-hand side, where's your graph going? Your graph is going up towards infinity. All right, and now let's take a look at our last one. So make sure that you've graphed this on Desmos and get your points, okay? Once we take a look at this, we should hopefully notice that this is an exponential growth function, since as we move left to right, it's going up. Your y-intercept right here, you're going to plug in x equals 0, kind of a funny number, 1.066. That's why you're going to want to use your graphing calculator or Desmos or something to get that answer. Okay, and now let's take a look at this. So my a value is 4/3. So that's, once again, since that's bigger than 1, that's going to tell me that's a vertical stretch. My R value, notice I don't have any parentheses, so what's your number in front of X? That's just going to be 1, so it's no horizontal stretch or compression. My H value, remember, is the opposite of what's next to here, so that's 3. So that tells us 3 to the right. And the K value is your number added or subtracted, that's 1. And remember that that's the exact same thing as your horizontal asymptote. So let's go ahead and label that in here. My horizontal asymptote is y equals 1. Domain, same thing over and over again. And for exponential functions, always the same. Your range, it's above your horizontal asymptote. So it's going to be from 1 to infinity. Once again, make sure that this is parentheses because you're never crossing that horizontal asymptote. And then this is going to be an exponential growth. Okay, and the reason it's an exponential growth is as you walk left to right, okay, as you're walking left to right, you're going up, 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 okay, and that's exponential growth. The other way to show is to take a look at this value, your base of your exponent, and that is a positive. Your number in front of x is positive, so 2 positives, that tells you that's an exponential growth. Now let's take a look at our EBM, reminder that's end behavior model. So as x goes towards infinity, where's your graph going? It's also going towards infinity. On the left-hand side, this is the side that's going to follow our horizontal asymptote. As x approaches negative infinity, what's happening to your graph? Your graph is actually approaching your horizontal asymptote of 1. All right, if you have any questions on this, please let me know.